Good day everyone. Now today's class we are going to look at friction force. I said it in the community forum that our next topic is going to be from friction. So if you look at the question display on the screen, you will see that we have two boxes, P and what and Q. In the question says the two boxes rather are of identical masses of what 40 kg. So the question asks us, we are given the friction force to be 0.20 and we are asked to calculate the acceleration used by each boxes and as well as the tension in the tie cord. So the tension here as well as the tension here is what we are asked to calculate. So the solution now, as we all know, this is solution. Now to do this, we must first analyze the diagram. Now if you look at that question, in the question, let's first of all consider, let's analyze this first. We have this. Now remember, in this cord there is tension there and the tension is moving this way. The two boxes are moving, this one is moving this way and this one is also moving downward. Now meaning the tension with which this one is moving with is moving along this direction. Are you getting my point? That means in here we are to indicate that the tension is moving like this. So this will be what? Force of what? Of tension, force of T. Now remember, as this object is moving forward like this, something happened to this box. Between this box and this smooth surface, there is a force of friction which is trying to oppose the movement, the forward movement. So that friction, if this one is moving like this, since it's trying to oppose it, then it will be moving this way. Therefore, we indicate the friction here to be force of friction to be F. Force of friction of what? Of P. Now, having done that, remember this object is exerting its own weight on the smooth surface. So that means the weight of this object will be like this, will be downward. That is force of what? Force of weight of what? P. That is Fw of P. That is the weight of what? P. Then there is an opposite reaction force, that is F of what? Let's name that to be F of P ordinarily. No, that is normal reaction. You know, normal reaction force. That's N of, let's make it to be N of P. Now we've analyzed this. Now the second one, now let's analyze this other one. Remember, it is in a slant form. It is in a what? A slant form. Now this one, the normal reaction, just like the other one, the normal reaction is going to be like this. That is F of N Q. F of N Q. And remember, as this object is moving downward like this, this object is moving like this, there is an opposing force here trying to oppose the movement. That one will be, let's tag that one to be F of FQ. Remember. Now the next thing, now if we look at this very well, this one, the tension in P is moving like this. Why? It's moving like this. Remember, it is the tension that will be affecting the free movement of this one. So if the tension in P is moving like this, then the tension in Q will be moving like this. So the tension in Q is going to be what? F of what? T. F of t. So that one is moving this way, while this is moving this way. Now, remember, this is an inclined, Q inclined at an angle of what? 30. So if we try to do that, the normal, this is your F of W. F of WQ, that is the weight of this object, will be in this form. Then this. Now let's look at this place. Now this is going to be our angle 30 degree. Now we are going to apply simple principle here now to know the forward force, the force here, and as well as the value here. Remember that this is just in this form. It's just something of this nature. 30 degree. Then we have this place to be FWQ, and that's going to be what? mg, because it's weight. Now we are calculating for this dotted side and this opposite side. That is, we are looking for opposite and adjacent. Now remember, SOHCAHTOA. If we use SOHCAHTOA, we are calculating here, this hypotenuse, adjacent and hypotenuse. Now if we use cos, so if you consider this, if we are finding, let's say we are looking for opposites, so let's use sine 30 is equal to opposite all over adjacent, opposite all over hypotenuse rather. What's our hypotenuse? Is mg. So in this regard, we are going to have our opposite to be equal to mg sine 30, and that's going to give us mg sine 30, and this is going to give us 40. Let's make our g to be 10 times 0.5, and this is going to give us 200 Newton. Do you get the point? So meaning here now, remember, according to what we have here, if I turn this thing like this, we are going to have it in this form, meaning this place is the opposite, and that's our what? This place is the opposite, and that's our what? Forwarding force. And that's going to be what? This is going to be what? 200 Newton. That is the force that is pulling that object down, is 200 Newton. Now, the car, that is, we are looking for the adjacent now. If we are looking for the adjacent is going to be the adjacent now. That's car. Cos 30 is going to be equal to adjacent all over hypotenuse. That's what? mg. And that's going to give us adjacent is equal to mg cos 30. And that's going to give us 40 times 10 times 0.8661. And that's going to give us, when we multiply, that's going to give us, so this is going to give us 346, approximately 346 Newton. Now this place now is 346 in what? In Newton. That is the force. Now we've analyzed this diagram. Now let's now calculate for each of the friction opposing each of the blocks in the diagram. Now if we are to calculate the friction opposing the movement of P, then we are going to have it. Remember that friction F of F is equal to U coefficient times the normal reaction force, which is the same thing as your FNP and FNQ. Now, to do this, we are going to have, let's consider for P now. We are doing for this is what we are calculating now. That is F of FP is equal to, what are we giving? We are giving in the question that we are giving the value of our coefficient of friction force. We are giving it to be 0.2. Now we are giving it to be 0.2 in the question. So if I use this place that we have UK now, the coefficient of friction rather, we are going to replace it with 0.2 times, what's our R? Our R is mg. And what's our M for P? This is going to be 0.2 times 40 times what? 10. So this is going to give us, when we multiply, it's going to give us 80. That is the friction that is opposing the movement of P is 80 Newton. Now let's calculate the friction opposing the movement of Q. That's going to give us FFQ, and that's going to give us the same formula applicable to that. That's going to give us 0.2 times, but here now, remember, look at what we have here. Remember, this one we are using this force calculated with this. So that is, we are using this force. Now this is going to give us 346, and that's going to give us what? 346 times 346 times 0.2. 346 times 0.2. That's going to give us 69.2. Approximately, it's going to give us 69 Newton. Now, we've calculated for the friction opposing each of the words, motion of each boxes. Now, what we are going to do now is to continue our calculation in order to, we will now use this to calculate for the acceleration as well as the tension in each boxes. Now, let's consider the first box. In the first box now, therefore, the sum to calculate the acceleration now, in the first box, the sum of the forces in P is going to give us, remember that if P is moving in this direction, this will be greater. That is, you are going to have this to be what? That is, you are going to have your F of T minus friction will be minus from it, minus friction in P, friction opposing the motion of P, that is F of Fp, and that's equal to ma. So what's the value of this friction? It is unknown. Force of tension rather, it is unknown, and the value of the friction is calculated. Friction opposing movement in P is calculated to be 80 Newton minus, that's what, 40 A. You don't know the acceleration, so let's have this now. Let's have this to be equation 1. Let's have this to be equation 1 now. Now in 2, in box Q rather, in box Q. Now, if you look at box Q, this is the force here that is moving this body downward. This one is greater than these two other ones now. Now, we are going to have this. Then the sum of the forces in Q is going to be equal to, that's what, 200 minus Ft. This is greater. So you minus these two from this. Since the body is moving downward like this, it's sliding downward rather. So minus F of what? FQ, and that's going to be equal to MA. Now 200 minus, you don't know this FT, that's the tension in the tie cord. So this F of FFQ is calculated to be 69 here. So this minus 69 is equal to what's M40A. So when we minus 69 minus 200 minus 69, we are going to get 131. We are going to get 131 minus F T is equal to 40A. That's equation 2. Equation 2. Now we can now use these two equations to calculate now. Now if I make from equation 1, let me make FT the subject of formula. If I make FT the subject of formula, then I'll be having FT is equal to 40A minus plus 80. So where I have FT here, I will replace it with 40A minus plus 80. Then I'll be having, therefore I'll be having this place to be equal to. So where I have FT in equation 2, I will replace it with 40A plus 80. So 131 minus 40A. So that minus here will affect this plus 2 to become minus. Minus 80 is equal to 40A. Now this one will come to this place. Then I'm going to have 131 minus 80 is equal to 80A. Now 131 minus 80 will give us 211 is equal to 80A. So divide 211 with 80. 211 divided by 80. Then we are going to have our acceleration to be by 80. We are going to have our acceleration. Then our acceleration by 80. Then our acceleration is going to be 2.6 meter per second square. That's acceleration. Now with this acceleration calculated, now we can calculate for the tension in the tie cord. So all we just need to do is just to substitute for the value of A in this equation. Now, so we have our F of T to be equal to 40 in this equation, 40A plus 80. Then let's replace where we have 40A plus 80. 40A plus 80. Where we have A, we are going to replace it with 2.6 plus what? 80. Then we are going to have our F of T to be equal to, so times 40 times 2.4, 40 times 2.6 rather. That's going to give us 104 plus 80. 104 plus 80, and that's going to give us 184 in Newton. So the acceleration of the body of each of these boxes is 2.6 meter per second, while the tension in the tied cord, the tension here is calculated to be 184 Newton. Please, I'm begging you in the name of God, don't forget to subscribe to this channel. More of these valuable things like this, solutions like this will still be solved in this channel. I am loyal. You can tell me whatever. If you have a question bothering your mind, you can drop it in the community section. Then we can treat it together under friction. If you have a question bothering your mind, you can drop it and then we'll look at it together. Thank you.